My name is Stephen Ayer. I'm an associate professor in our School of Sustainable Engineering and the Built Environment. I study new and emerging technologies. My focus is not on the advancement of the technological tools, but the understanding of how those tools support the human user. So one of the studies we did is we took augmented reality, which blends the virtual over top of a real view of a space. We've adopted now something that we call building information modeling. This is kind of CAD meets database. So it's basically making a virtual version of our building that possesses intelligence to know a door is a door and what are the properties of that door. And we use this because we can then use that virtual version of our facility to iterate, try and fail in an environment that's way cheaper than the actual environment, so that when we start to build, we're informing our process based on that virtual design and construction experience.
Traditional blueprints, they're on a flat page. If you're looking at a design in augmented reality, you're seeing 3 dimensions. So to be able to provide students a tool where they can engage with the spatial thinking in a very literal and physical way will allow them to be able to go into their careers knowing how this flat page might become a building and be able to see that in a way that makes sense intuitively and visually.
What we found is that we can build in about half the time, and we can reduce errors by about 75%. So that's an example where we try to use a technology, augmented reality, to support the human user, in this case, the people who are building, putting elements together in the built environment so they can do their jobs faster and with fewer errors. One of the studies we're doing uses a technology called virtual reality. Unlike augmented reality, virtual reality is a completely synthetic environment, and we're using this for construction safety training. We still continue to lose about 1,000 people annually from preventable construction deaths.
Traditionally, how they used to do safety training is in a lecture setting where construction workers went to a classroom or like a seminar. It was much different than the actual working environment, which is the chaotic construction site with loud noises and heavy equipment going around you. So VR helps us bridge that gap where the trainee is safe in a safe environment, but also in a realistic, chaotic environment of the construction site.
A lot of student developers helped with this. We're really fortunate at Arizona State University. We've got computer science students that will do capstone projects, and they'll develop pieces of this environment. They develop the hazards, they incorporate sounds, they incorporate animations. We've worked with motion capture suits, they incorporate haptic feedback in specific ways, spatial audio. There is a lot of work that goes into this.
And sometimes these students get so involved in creating the project because of the value that this brings, right? It's so close to safety where you're eventually saving people's lives.
We might save lives. And to me, that is something that's just immediately intriguing and feels sort of deeply fulfilling in a way that it's not just playing with some new gadgets, it's doing something that might actually matter.